Assalamualaikum and a very good day. My name is Muhammad Karafik bin Muhammad Kadapi. Today I will be presenting my final year project on cancer risk analysis of personal benzene exposure to workers in the paint manufacturing industry in Bangi. My main supervisors is Associate Prof. Norma Awang. My main co-supervisors are Dr. Nurul Farhana Kamaluddin and Dr. Muhammad Ikram bin Abdul Wahab. These are my outline for my presentation. Firstly, the introduction. Benzene. Benzene are organic chemical compound which has gasoline-like odor and volatile. Benzene is the simplest polycyclic aromatic hydrocarbon or PAH, and it has 6 carbon atoms joined in a ring with 1 hydrogen atom attached to each. Benzene is classified as type 1 carcinogenic agent. The primary use of benzene are manufacturing of organic chemicals such as paint and rubber. My literature review are by Harati et al. 2016, several effects of volatile organic compounds or VOCs have been recognized such as toxic and carcinogenic human health effects. Next, health effects from long-term or chronic exposure to PAH may include decreased immune functions, cataracts, kidneys and liver damage, breathing problems, asthma-like problems, and lung function abnormalities. By Abdul Shafi et al. 2016. After that, its synergistic action with other pollutants can damage different components of the biosphere by Sekar et al. 2019. Lastly, benzene exposure potentially increased the cancer risk for 17.67% of workers in gasoline station by Checkling et al. 2019. The problem statement for my FYP is epidemiological studies have shown benzene causes the occurrence of acute and chronic leukemia, even at low concentrations by Rinsky et al. 1987. Next, exposed workers that influenced by benzene and ethylbenzene would increase the risk of them getting cancer. Now, for my research justification, preliminary study on personal benzene concentration exposure in paint manufacturing industry in Bangi, Selangor. Next, a gasoline-like scent of volatile organic compound, VOC, likely to be benzene during our pre-visit there. After that, lack of local data on personal benzene exposure concentration. Finally, there is a high risk of cancer as benzene is classed type 1 carcinogenic agent. Now for my research question, is personal benzene concentration exposure towards workers in the company exceeds the permissible exposure limit for Occupational Safety and Health Act 1994, which is OSHA 1994, and posing cancer risk? My hypothesis is the personal benzene concentration exposure exceeded permissible exposure limit OSHA 1994 and posing higher cancer risks for exposed workers. Now this is the permissible exposure ppm. The regulation is OSHA 1994. The time with average for the benzene is 0.5 ppm. My general objective for my final year project is to determine the personal benzene concentration and the status of health risk assessment among paint manufacturing workers. For my specific objectives, it is to determine the level of personal benzene exposure among workers at breathing zone using NMAM 1501. Next, to compare the level of personal benzene exposure between exposed and non-exposed workers. And finally, to determine the cancer risk and comparing them between exposed and non-exposed workers. Now for my methodology. Firstly, this is my research flowchart. As you can see, first is to find out workers at paint manufacturing industry. My inclusion criteria are exposed workers and non-exposed workers. After that, it is the determination of the personal benzene concentration exposure by using personal air sampling NMAM 1501. After that, run the chemical analysis by using GCFID. Later on, health risk assessment of benzene exposure concentration, which is cancer risk, and lastly, the statistical analysis. Now, for my study design, this is a cross-sectional study to find out the personal benzene concentration exposure towards workers in a paint manufacturing industry. The inclusion criteria are workers aged 25 to 50 years old and workers that is exposed and non-exposed, which is in working in administrative for 1 year and above, which work 8 hours a day. Now this is my sampling tools. First, I will use air sampling pump with known flow rate between 0.01 and 0.2 liter per minute, which will be used 8 hours, and using the method NMAM 1501. For the sampler, I will use solid sorbent tube, which is coconut shell charcoal, and 100 milligram front and 50 milligram back, and also using NMAM 1501. This is the instrument for benzene analysis. I will be using variant C3800 gas chromatography GC that coupled with FID or flame ionization detector. Now, for my study location, it is located at paint manufacturing industry in Bangi, Selangor. Sample population are non-exposed workers 25 and exposed workers 25, 50 workers totally. The health assessment for benzene concentration exposure, this is the formula that I will be using to determine the cancer risk. First, the breathing zone exposures were estimated in terms of chronic daily intake or CDI in mg per kg per day for cancer risk assessment using the equation chronic daily intake CDI equals to Ca multiplied by IR multiplied by ET multiplied by EF multiplied by ED divided by body weight multiplied by averaging time. These are the description for each acronyms. Ca for contaminant concentration in air, IR inhalation rate, which is 0.875 meter cube per hour, ET exposure time, which is 8 hours a day for workers, EF exposure frequency, which is 350 days per year assumed for the workers, ED exposure duration, where 30 years for workers, BW for body weight, 60.54 kilograms average body weight of workers, AT averaging time, 70 years multiplied by 365 days for cancer. Next, for the cancer risk, I'll be using this formula, which is CDI multiplied by CSFI. CSFI is the inhalation cancer slope factor, and for benzene, CSFI is 0.0273 mg per kg per day. No specific guideline value has been developed for air, and benzene is carcinogenic to humans, and there is no safe level of exposure that can be recommended. For general guidance, the concentrations of airborne benzene associated with an excess lifetime risk of leukemia of 1 multiplied by 10 to the power of -4, -5, and -6 respectively by World Health Organization, and it cannot exceed this limit. Then, after getting the data for personal benzene exposure concentration and cancer risk, now we can proceed to do statistical analysis. First one, the specific objective is to identify the relationship between level of exposure of benzene and cancer risk of workers through HRA. I will be using Pearson's correlation. The second one, I'll be using independent t-tests to determine the differences of personal benzene exposure between exposed and non-exposed workers. The last one is also using independent t-tests to determine the differences of cancer risk between exposed and non-exposed workers. This is my Gantt chart for my final year project. And these are my references. That is all from me. Thank you.